Hey guys, this is PrepTest 67, Logic Game number 2 from the October 2012 LSAT. This is the professor's giving guest lectures game. It's an ordering game, also known as sequencing, because we're taking the 7 professors, P, S, T, V, W, Y, Z, and placing them in order from 1 through 7. Now I've laid out a lot of rules here. I'm going to explain all of them. They tell us that P is before W, that T is before S, and V is before Z. So based upon that information, we can represent a number of restrictions on the diagram. We know that P is never 7th, W is never 1st, T is never 7th, S is never 1st, V is never 7th, and Z is never 1st. Additionally, we know that Y is not 7th, we know that S is no later than 3rd, therefore S cannot be 7th, and we know that if P is 1st, then Y is before V. But we also know that the reverse is true, that if Y is before V, then P is 1st. The if but only if creates a double arrow situation in which each condition is both necessary and sufficient for the other to occur. And based upon this information, we can infer that Y will never be 1st. Because if Y was 1st, then Y would go before V, and if Y goes before V, then P is 1st. But if Y is on 1, then P cannot be on 1. Therefore, we can infer that Y is never on 1. And if you look at number 7 here, we have 5 different variables that cannot be 7th. So if you look at the 2 variables that remain out of the total 7, you have either W or Z being 7th, which is how I inferred this piece of information. Now, they told us that S is always in one of the first 3 slots, but because S cannot be on 1, I've inferred that therefore S will be on either 2 or 3. So this right here is our very bare bones initial setup for the game. We'll infer a lot more over the course of the questions. Now question number 6 is a typical orientation question. We'll just take one rule at a time and apply that rule to all 5 choices looking for violations. So we know, for example, that either W or Z will always be 7th. So looking at our choices here, we have choice D with Y on 7th. That's unacceptable, so D can be eliminated on that basis. We know that S will always be on either 2 or 3, so any choice violating that is automatically gone. Therefore, A can be eliminated. We know that P on 1 requires Y before V, and Y before V requires P on 1. So choice A was already gone, had P on 1 comply with the rule. We have Y before V occurring, let's see, where do we have Y before V? In choice E. Y is before V, but P is not on 1. Therefore, E can be eliminated. We're down to B and C now. Now let's go back to our initial rules, P before W, T before S, V before Z. Choice C, P before W occurs in B, P before W does not occur in C, therefore C is gone, leaving B as our answer for number 6. Next, number 7, typical could be true question asking us who could be on number 1. We know that none of W, S, Z, or Y can be on 1, so for that reason A, C, D, and E are eliminated, leaving B as our answer to number 7. Next, number 8, who cannot give the second guest lecture? Well, looking back at question 6, choice B, we saw that P could very easily give the second lecture, so for that reason alone A can be eliminated. Now, we don't have any other previous valid scenarios to draw upon here, so I would actually skip this question and come back to it when we have more valid scenarios to help us eliminate wrong answer choices here. Next, number 9, if S is on 2 and Z is on 4th, what could be true? So S on 2 and Z on 4, I'm going to eliminate S from 3 there. I'm going to put Z on 4, and we'll see what happens as a result. Well, we know that T is always before S, so S2 requires T on 1 off the bat. We also know that V is always before Z, so therefore V will be on 3. Nothing else immediately follows from this. Things are still a little bit open-ended. We know, of course, that since Z is on 4, Z cannot be 7, therefore W is on 7, and then we have P and Y remaining on spaces 5 and 6 pretty much interchangeably. So what could be true? P on 6, absolutely. So A is our answer to 9. I will run through the rest though. T on 3, no T's on 1. V on 5, no V's on 3. W on 5, no W's on 7. Y on 3, no Y's on either 5 or 6, leaving A for number 9. Next, number 10. Where can't V go? Well, we know that V can't be on 7 because we have it indicated right here and because V is always before Z. Therefore, choice E is our answer to number 10. Next, number 11. If Y is on 4 and if T is on 1, then what must be true? So we know that we always have to have T before S, and S has always got to be either 2 or 3. We know that we don't have P on 1, therefore we cannot have Y before V. Therefore we have to have V before Y. So S and V are basically interchangeable on 2 and 3 here. S slash V, V slash S. Everything else pretty much open-ended. So we'll just have to go off this information right here. What must be true? P no earlier than 6? No, that's not necessarily true. We could have P earlier than 6 on 5 right there. So A is gone for number 11. Looking at B, S on 2. No, S could be on 3 as well. V no later than 3. Yes, because V is either 2 or 3. It could never be any of 4, 5, 6, 7. So for that reason, C is gone. C is actually our answer. Now, I'll go through choices D and E now as well, though. W on 7. Not necessarily. It's either W or Z on 7. W could actually be earlier, so D is gone. And then Z no earlier than 6. No, Z could be later, could be on 7, so E is gone as well, leaving C. Next, number 12. If Z is 4, what could be true? So if we put Z on 4, and we know that V is before Z, we know V will have to come earlier than it somewhere. We're also going to have, of course, T before S on 1 or 2, and then everyone else will go later as a result. So we've got P, Y, and W coming later, which means, of course, that W has to be on 7 since Z was on 4. We're going to have P and Y interchangeable on 5 and 6. So what could be true? P on 2, no P's much later on 5 or 6, so A is gone. P on 7, no W's there, so B is gone. W on 3, no. We've got V or S there, basically, so C is gone. Next, looking at D, Y on 2, no Y's on either 5 or 6. But yes, Y on 6 is entirely possible, so E is our answer to 12. And now, let's go back to question number 8, which we only eliminated A for. So at this point now, we saw from question number 9 that we could very easily have S on 2. So for that reason, B is gone, and we saw from questions 11 and 12 that we could again have, V or S on 2. So for that reason, we can eliminate both B and D. However, C and E remain here. But if you play with our work for number 12 for just a minute here, we could have had T on 2, S on 3, and V on 1. So for that reason, we do actually know that it's entirely possible to have T on 2 as well, which gets rid of C, leaving E as our answer for number 8. Now I'm going to show you why W could never be on 2. If we were to have W on 2, we'd have to have S on 3 because S is always on either 2 or 3. And now we have to have Z on 7 as a result. So if you think about, P1 requiring Y before V, what happens? We put P on 1, we're going to have Y before V coming later. P before W is good, but T before S cannot fit. So for that reason, we cannot have P on 1 when W is on 2, but P's always got to go before W. Therefore, we hit our roadblock. This doesn't work. That's why W on 2 can never happen, so E is our answer to number 8.